Hello friends, आपको नमस्ते. So today in this video we will create a team color assigner or team player color assigner. As you can see, the player who wear green jersey is represented by the green bounding box, and the player who wear the white jersey is represented by the white bounding box. So how we can do that? We have to just follow this. We can say follow. I have to explain this whole code and follow the steps so that you can get better knowledge step by step what is happening here. So let's get started. Before that, let me show you the input video which we are using. This is the input video which we are using for detection purpose and color assigning. Okay, so let's get started. The first step is that import required libraries for videos, MLN Vision, and load the input football match video and read video frame by frame using a while loop. So let me comment the other whole things and come back with these three steps only. Okay, so wait for the seconds. So it's done. The required libraries are CB2, NumPy, KMeans. Yes, I want to say that we are using the KMeans for a team color assigner, and we are using a YOLO model for detecting the player. Okay, so don't and we this is a model which we are using bash.bd. Okay, so YOLO we are using for uploading the model. The model this is bash.bd. Okay, so and this is how you can say these are the helping functions which I have created. Okay, and using the while loop, first we have to load the you can say the video. So this is v2.video capture input video input.02.mp4 will import the you can say the cap video, upload the video, then we have to read the frame video frame by frame. So how we can do that? Just we have to use while true cap.read, then ret and frame will be the image, and ret will be the you can say is a you can see the bool boolean data type, or you can say the boolean data type. It is result whether the frame is there or not. If it is false, it means the video is ended. If it is true, yes, video is there. If it is false, it will break the while loop. And after that we will resize the frame into 1280 and 720, and we will show that you can say frame. And if it is as soon as I press S, it will break the loop and everything will get vanished. And here we are releasing the we can say a memory. So this is done. Now what is the fourth step? Load the YOLO model to detect player, wall, and referee. So this is the model which we are using. Okay, and it will detect wall, goalkeeper, player, and referee. And the player you can say index value will be 2. So this way we load the pre-trained model. Okay, model.yolo, then just load the model. And after that, what is the second fifth step? Detect all object, player, wall, referee in each frame. But here we just detect player only. Okay, so let me come back. Let me comment everything. Sorry, let me do this part. Okay, okay. It will also get when problem. So not that much problem will be there. Okay, it's problem. Okay, I have to use this thing also. Okay, it will detect everything. Now let me copy this line and paste it here. We are just want to draw the bounding boxes right now to detect player only. Okay, nothing else. This is a line which I will explain later. Okay, according to the step only we are going, so don't worry. So for player detection, just the color will be right now color will be blue. So 255 comma 0 comma 0. So everything will be done. Now let me run this. Okay, my GPU is not that much good, so don't worry. Oh, so let me explain what is happening here. For now, just pass the model.frame.0. We will get we are passing the single frame, so we get the result. To get the result of the single frame, we have to use 0 index value. After that, after getting the result, we have to get the bounding box coordinates values. So for that, we have to use result.boxes, iterate over the boxes. How many player is detected? It will iterate over that. After getting the box, it will have a x by 0 index value to get the coordinates values. Dot CPU means YOLO is trained on GPU, so we have to means we have to you can say store the values from GPU to CPU and convert that into numpy, because initially it is in tensor format or in other format. As tab is, I have to convert up that whole thing into int format. So this way we will get the xy coordinates values. Let me explain you again. Zero index value, get the xy coordinates values. CPU means we are moving the coordinates value from GPU to CPU, converting to NumPy, then converting all you can say the coordinates value into int format. After getting this, we have to also get the class ID. So for getting the class ID, we are just used to box.class 0 will give me the class ID. We have to convert it into format. After getting the class ID, you can see that the player is detected. I already told you the index value for the player will be 2. So if class ID is equal to true, means draw boxes, and we will directly call the draw boxes, you can say function. In this, you can say we have a draw boxes function here. Okay, I will explain you what is happening here. Don't worry. We are passing the frame, then the bounding box coordinates value, then the text which we want to display, and the color. And this way we directly show the frame. Now let me run this. Then after that, I will explain you draw boxes function. Wait for the seconds. So this is a window. Okay, so blue color is you can see it there. Text is there, bounding boxes of blue color, and see what is happening. Now let me explain you what is happening in my draw boxes function. In my draw boxes function, see, after cutting the image, then the box coordinates value, then the label and the color. The color is see what is happening here. I will not explain. Don't see here. Just see that is a simple color, RGB color. I will explain what is happening here later when I will come to the steps. So don't worry. Just color you can see. Then we will unzip it, or you can say we have to expand the box variable. We have to get xmin, ymin, xmax and ymax values. Xmin, ymin just basically the, you can say, top left corner of the bounding box. Xmax, ymax is the bottom right corner of the bounding box coordinates values. We have to just plot the, you can say, rectangle using this xmin, ymin and the color, and this is 2 is the thickness. After that, you can see that let me play my video, output video. Sorry, this is input video again. Output video. Okay, as you can see that in player, when you will run this, you will see that the player is having this thing, this rectangle with same bounding color, and the player of text with black color. How it is happening here? So let me explain you this thing. See, let me first pause this video. Let me pause this video and come back here. As you can see, after drawing the bounding box, we get a text. We have to get the text width and height. So how we can get that? Using this get text size, text font which we are using, 1 and 3 is, you can scale and thickness. And after that, we will get that text width and height. According to that, we have to decide the rectangle. We have to decide, suppose this is this rectangle, this color filled rectangle, this coordinates value, top coordinates top left this coordinate value, and bottom right this coordinate value. How we can decide that? For that, we have to just decide the text width and height. So that's why after getting a text width and height, we have to decide y means top left coordinate value for that particular rectangle, text rectangle. For that, you multiply a y mean minus th, then minus 5 pixel for the you can say boundary, or essence space or padding, you can say. And 0 here being max value from 0, because y value will be less value will be 0 0, so max value will be decided here, so that bounding box does not go beyond the around beyond the frame. So that's why after getting the ymin text, we will get image, and these are the coordinates value of the rectangle, filled rectangle of the color the same of the bounding box color, with the x mean and y mean text minus 5 means 5 with just adding some padding, and rectangle bottom right coordinate value will be x mean plus text width plus 10 for adding some padding here, and y mean, and this will be minus 1 is just we fill that particular rectangle with this color. After that, we just put the text here. Okay, so this way we create this So this rectangle with the text above the bounding box of the same color. So this is happening here in a draw bounding box. Now come back to the code. What is happening here in the next code? Next step is what initialize empty list to store player jersey color. Okay, and for first few frame extract jersey color of each player, store extracted color in the list. So what is happening here? First is initialize empty list to store player jersey color. Initialize empty list to store player jersey color. So this is a list, player color, this is empty list, you can say. And then how many player color we have to player colors, you can say, we have to store 60 player color we have to store. So let me uncomment it. Now initialize the team color assigner will be none because we are not using it KMeans here. So team color assigner will be none here. Color collected, yes, initially it's act as a flag. For that it is initially is false. After the 60 player player color is you can say created, or you can say they is collected, its value will get true. So this is happening here. So come back here and I will explain you what is happening here. Okay, so color collected first 60 frames for sorry 60 player, not for 60 frame. For 60 first 60 frame we will collect each player jersey color in this particular player color, because we want to make means to we want to get the two clusters, and after getting the two cluster, KMeans can easily detect which team color is this. So don't get confused, let me explain you. If not color collecting, if it is false, it will go past the it will result dot boxes, it will iterate over it. After getting the xy coordinates value and class id, and if class id will be 2, we will first get a get player color. Now one thing is happening here, we are just passing the frame and the bounding box. So first of all, I want to tell you that the method which I am using, let me tell you what is happening here. Let me see images chest reason. You can see these are the bounding boxes. So these are the bounding boxes. You can see the player I have extracted here, and you can say to get the best color of the jersey is a chest region. Is a you can say oh sorry is a chest region we get a best color of the jersey. That's why I have extracted a chest region. In every bounding box I have extracted the chest region so to get the best color of the jersey. So this way what I'm doing here, and to get it I have just called the get player color. It will go here, get player color, it will get the frame and the bounding box. Then we have expanded the bounding box x by and by x max by max. After that we will extract the, you can say, crop the player from the frame. We crop the player from the frame using this. Okay, after that if the player size image size will be 0, it might be possible that the crop region will be 0, so it will return none. Otherwise we will get the shape of that particular player, height and width, and here this one, using this line will get a chest region. Okay, crop chest region means 25% and 50% from the height and 25% 75% from the width. We will get the chest region. I have calculated, that's why I use 25 and 20 55 and 25 and 75. Okay, so through this calculation, we can easily extract the chest region. It might be possible the chest size will be 0, so that's why it written none. And here, what is the main thing is here to get the stable, you can say, stable color of the jersey in without effect of this lightness or brightness. You can say lightness. Without do we have to convert that chest region in a lab format. You can say you can read it, convert chest area from BGR to lab for stable color detection. Here lab a color space that separate an image into lightness, and two colors channel, a green and b blue yellow. This way we get the stable color of the jersey after converting the chest region from BGR to lab. After getting it, we have to means what is happening here, filter all lab pixel and compute the median lab value. So let me come back with some calculation here, what is happening here, so you will don't get confused what is happening here. For the explanation purpose, let me come back here. Okay, So friends, come here. Let me explain you what is happening here. So in this function, I have all printed, I have separated all thing. I have printed this all thing h into 0.25 and everything, and crop. Then I have printed reshape -1 3 and shape 0. Then the length into chest length. What is happening here? Let me explain you. Suppose for I am talking about the first detection only, first detection player I am talking about, and I want to get the jersey player. How we are getting it? This will get past this get player color. This function will be called, and inside this I have printed edge this coordinates values edge into 0.25 edge into 0.5 chest region, and after that I have printed chest lab. Here I am reshaping, reshaping chest lab. Lab is basically chest lab, basically you can say chest region. So how chest lab into reshape -1 into 3, okay, and chest lab shape 0 and chest lab dot into multiply it. And what is happening here? Basically here it give me how many pixel value in that particular chest region, how many pixels are present, number of pixel give me in this. It give me same thing after reshaping. After reshaping, what is the length of that? And you can come, you can see that both get same value. It means after reshaping we get a same value, and after multiplying we get the same value. Number of pixel value will be same. And what is happening here? NP medium just label dot reshape -1 into 3 axis 0 give me the medium pixel value from that particular list after converting it into a list for into list. Okay, so let me come here. So these are the coordinates values. Y1 22, it's come here, near to here. Y2 48, near to here. And x1 12 come to near to here. And x2 36 near to here. We will extract that and we get a chest region. After getting the chest region, you can see I have converted this into a you can say reshape it into -1 3. Okay, and 3, what is why here 3? Because we have a 3 channel L, A and B. We have a 3 channel, that's why we have here 3 here. And after reshaping it, we get a list of this thing. Okay, and you can get, you can see that the pixel value, number of pixel value will be same, 624 624. And you, when you will do the median, you when you will do the median and put on median, you will use it, you will get the median pixel values, lab values of the median pixel value, and you will get this color, this, sorry, this pixel, this color, you can say list. Okay, this color will be there for that particular jersey. This way we are extracting the color from the jersey of the player. And also I have tell you why we are using a chest region. So this way it will return the color. Come back to the see, after getting the player color, we will append that player color into a player color list. And just we use length color collected length of the player color we printed. After that, if the length of the player color is greater than or equal to color collect limit. Okay, so friend, here I'm talking about the color collect limit. Means collect limit is 60, means 60 player jersey color we are collecting. And let me explain again. We are not collecting 60 frame player jersey color. We are collecting 60 player jersey color. Okay, after doing it, when we will get the 60 player jersey color, it will go come here, it will decide. We can now we have to decide the team, we have to assign the team color assigner, which decide the jersey color of the player. After getting this, we have to make the two cluster, and initially it will be 5, means. Okay, so here what is the meaning of this and init is run this KMeans clustering 5 times and just select the best one among them. Where the error is lagged, that team color assigner will be selected. Now what is happening here? Here just when we pass the player colors, it will see what is happening here. It will divide those color into two clusters, and into two cluster. After that it will select randomly select the centroid. And if it randomly select centroid, it will you can say calculate distance of each color with that particular centroid, and see what is happening, and see the inertia. And where the inertia is less, that particular you can say you can say K-means cluster model will get selected. and this happened 5 times, and it is just used so that it will do 5 times, and 5 times this process, and after 5 times it will select the best one, team color assignment. So this way, after that we will you do color collector will be true, and this way continue. If color collector will be true, it will not go here. Okay, it will not go here, it will correctly come to here and just display the, you can say, display the bounding box. Now we have to do the main part. After 60 player jersey color collected, after K means after our team color assigner will get selected. And one more thing, let me come back here. So it's not here. After team color assigner will get you can say there. So let me do this part. Control plus C, and after this let me print it here, so we will not get what is happening here, why we are doing it. Print. In zero index value of this particular team color assigner cluster center 0, you will get a team color different color, and this way you will get a different color. So after that let me comment this part, and what is, I have to break the loop, and if length of this is continue, then just break the loop. I want to do the breaking of the loop, where I will do it. I will just press the S, you will get everything here. So let me run this. Okay, let me first save everything. Okay, what is happening? Save everything. Now let me run it. I want to tell you what is happening here when we just pass the 60 player jersey color, and our team color center is ready. So what is this cluster center 0 cluster center 1 is, what is this? Let me explain you. Okay, let me break this loop as everything will get vanished, and you will see this two thing will get there: zero index value, this thing, and one index value will get this thing. What is this thing? Okay, let me for a better explanation, let me comment one thing. This is team team one color. Team one color is decided, and this is team two color is decided. Using this 60 color jersey color, we have decided two colors. Okay, finalize the two colors. Okay, now after when we just pass the team jersey color of the player, it will predict which color, but means which color is that particular player belong to. Okay, so let me open one thing. You can see here 21888. 21888, and last one is 170. Okay, let me run it. 21888 and 170 is this color. Okay, and second one is 216, 216, and 123, and next one is 127. Now you will get confused that why this color is this one and this is not, why it is not green or white, because it is in a left format. When we convert this into the left format, and then after converting the left from left format converted to BGR format, we will get the exact color. So let me show you that thing also. For that I have to call that function. So let me come back with some RGB's values after converting it. So let me come back. So as you can see that these are the values I have just pasted here. Make a list of that. This is a function where it is a function. Okay, I will explain you. This is just pass the color. It will convert that into the BGR color format. After that, just we have to use tuple map int and team color assign. We get the exact color which is converted from lab to BGR, and these are those color which is in a BGR format. And okay, when you will see, when you will run this in this 131, 232 and 161, you will get this green color. And when you will run this 213, 14 and 200, you will get white, near to white, and this is near to green, or the jersey color which is the player is wearing. So this way we get the team A color and team B color. Okay, see here we are converting into the BGR, so this way we get it. Now you will get this thing 161, 121, 232 and 161. Okay, so now let me go back to the code and see here. So this way we assign the team A color and team B color using the index values or the with this cluster 0. We will get team A color and team B color this way. Now just a simple thing, now just a simple thing. Our team color assign is ready. Just to predict it, we will just after 60 players getting this, the loop will come to this for loop just for do the detection, and bounding bus will be there. Just get a player. How we can get a player ID, whether it's team 1 or team 2, how we can get it? Just use this thing here, just passing. Here we are just, I have explained this whole code. This is the code which is next one. Team color, just passing the frame, then the box, the model will be K-means. After getting the color, just pass this frame and the box, bounding box coordinate value. It will come here. I have explained you everything. It will give me the color. After getting the color, it will not, it will return 0. After it will just give me we will just pass it into this format. Okay, here reshape is there required because he will reshape it into from 2D to 1D. We have to reshape it. After this, after you can say here initially the color is in a 1D format. We have to convert it into a 2D format just to pass it into the model or predict. Okay, so that's why we are using color dot reshape my 1 minus 1. You can say predict team I1D using KMeans clustering model and 0 index value. We will get a, you can say team ID. Team ID, it's here, it will be 0 or 1. Okay, so after plus we will plus 1 will get a team, whether it is team 1 or team 2. Okay, let me explain you again that here just color is in a 1D format, so we have to convert it to 2D format. That's why we are using reshape 1 minus 1, and here just passing it in a 2D format. It will predict it whether it is 0 or 1. When just we have to add 1, we will get a team ID. After getting the team ID, whether it is belong to 1, we will just pass the color this 0 index value, and if it is team 2, then we just pass this 1 index value. So this way our bounding box and team color assigner is working. Okay, and I have explained you everything line by line. Now let me run this file. So everything will be, I have explained you step by step. K-means divide player into two teams based on jersey color. After team color are learned, stop collecting colors. For every new frame, predict each player team ID, drawing bounding box, and this way our step is over. Now let me run this file and our video will be played. Okay, wait for the seconds. First it will collect, see, after collecting it will just give me this thing. My GPU is not that much powerful, you can see, but it's working very well. Okay, so let me, oh, so I already played the video, so this is that particular output. You can see it's working very good. Team color assigner. So I have explained you each and everything line by line, step by step. I have explained you how it is working, how we are first we have to collect a 60 player jersey color. That is, okay, means we have to make the model, it make the two cluster, and it mean 5 round will be there. Center, best center will be selected, best model will get selected. After that, it will give assign the team one color, team two color using 0, 1 and 1 index value. And after we have to just play predict means just get the player color, predictor color ID, but index value 0, 1. After that, we get a team ID, and after that we just have to pass the color. This way, our team color assigner is working. So I have explained you each and everything. So please like, share, and subscribe. Thanks to all.